Yeah, very good morning. So last time in the last lecture, we have defined uh, the meaning of when we say a given standard form of first order differential equation will be exact or non-exact. It's some can be uh, specified by the criteria. So the criteria was if you have dou m by dou y equals to 2n by 2x, then the equation is said to be exact differential equation. And if they are not equal, then we say that it's a non-exact differential equation. Sorry. Not that m is the coefficient of dx, n is the coefficient of dy. M is a coefficient of dx, so you are differentiating partially with respect to y, so another variable. Similarly, n is a coefficient of dy, you are differentiating partially with respect to x. Okay, so it's very easy to memorize this thing once you do 2-3 problems here. Okay, now in case of exact differential equation, we have seen 2 examples how to solve. Okay, and then we have looked after for non-exact differential equation where these two things are not equal, and we search for a function mu which may be a function of both variable x and y. Okay, maybe a function of single variable, maybe a function of x or y, or of both, which is said to be an integrating factor. Okay, so we are in search of such mu, so that if you multiply the equation by mu both sides, the resulting equation becomes an exact differential equation. And then what we have process opted for solving the exact differential equation, then we can apply for the resulting equation. Okay, right. So this was done, and we have looked on 4 methods. Okay, in which case this integrating factor will be a function of x only, function of y only, and in case when m and n both are of homogeneous functions of same degree, then you have this 1 by mx plus ny is an integrating factor, or if this m and n are of specified form, okay, then you have another integrating factor 1 by mx minus ny, provided the denominator should not 0. And we have done 1 or 2 problems in that respect as well. Okay, so now, so since see you have introduced one new function mu, which is called an integrating factor, after which after multiplying this factor to the original equation, the resulting equation becomes exact differential equation. So there will always be some payback. Okay, so what will be the possible paybacks are the multiplication of original equation by the integrating factor may result in either it may be you may lose the solution of the original one. Okay, so one or more solutions, so there will be infinitely many solutions, right? Because if you specify initial condition, then only you will get the unique solution, otherwise there are infinitely many solutions. So after multiplying by an integrating factor, there is a chance that you may lose one or more solution of the original, or or you may gain one or more functions which are solutions of the new equation but not of the original. Okay, so number of solutions may become more, such type, or mix of these things. Okay, right. So let's see this example here. Now see this equation here. So it's very clear y equals to 0 is a solution for this. Okay, because y is 0, so the first term will 0. This will satisfy. Dy is also 0. Okay, so 0 minus 0 is equals to 0. Y equals to 0 is a solution for this case. Now if you try to identify, so this is your m and this is your n. Now, what is dou m by dou y? For this case, is going to be 4 times x minus 4 y cube. Okay, and what is dou n by dou x? That's equals to minus 3x square time y square minus 3. Now, both of them are not equal, right? So it's a non-exact differential equation. Now, what I can do is I can I can multiply both sides by 1 upon, I'm carefully multiplying x cube by y to the power 4. Okay, so I am carefully multiplying by x cube times y to the power 4. I'm just choosing this. Why it is so? That is by intuition only. Why? Because see, dx coefficient sitting with some function of y that I'm bringing here, and dy coefficients are function of x, which is easy to remove, and resulting is nothing but here function of x, and here is function of y only. And then dou m by dou y and dou n by dou y, the resulting equation becomes 0. Okay, so this is by intuition. So by guessing, you can say. Okay, so once you have this, so then you can see what is mu m is going to be x minus 4 by x cube. So that's going to be 1 by x square minus 4 by x cube. And what is mu n is going to be is wait a minute. Yeah, so x cube will get cancelled. Yes, so minus y square minus 3 by y to the power 4. So I can still write 1 by y square minus 3 by y to the power 4. Now you can look at the resulting equation. Okay, so I'm now writing the resulting equation, and then you tell me whether y equals to 0 becomes a solution for this or not. Okay, so what is the resulting equation? So I have this is let me write it, x minus 4 times y to the power 4 dx, okay, minus x cube times y square minus 3 dy equals to 0. It's a for this dou m by dou y is not equals to dou n by dou x. That's what we learned just now. Let mu of x comma y is equals to, we have already defined, 1 upon x cube times y to the power 4. Okay, so now multiplying 1 by mu of x comma y. Okay, so what you will result, I'm writing the simplified form, that is going to be 1 by x square minus 4 by x cube dx minus you have, this is going to be 1 by y square minus 3 by y to the power 4 dy equals to 0. Now it's very clear that if you take y equals to 0, this coefficient is not defined. Okay, 1 by 0 is infinity. The limit at y tends to 0 does not exist here. Okay, so y equal to 0 solution is lost here. Okay, so you have a loss of solution. So similarly, means like I'm not going further now for what is the gain or, okay. So you have an example here. So you may, there be a chance of loss of solution, loss of some solutions. Okay, right. So this equation, so this is a resulting equation which you may call, this is some m tilde, and this is your n tilde. Now, because it's a modified equation, or you have m tilde is nothing but mu m, n tilde is nothing but mu n, and you can verify that dou m tilde by dou y is equals to dou n tilde by dou x, that is equals to 0. And both are equal. Now resulting equation is an exact. Okay, and you can perform that procedure here. Okay, so dou f by dou x is equals to this, dou f by dou y is equals to this, just you try to identify that f here. Okay, so that is the easy part is that you can do once, because
Sir,
you are going to integrate. Yeah,
how do we get mu of xy in this sum?
I told you that is a by intuition. I'm telling you. So this is a intuition method. Okay, it's a intuition method. So that's why this is not. It's like always. It is not possible to get that intuition. This only comes with the practice. Okay, so intuition means you are guessing what will be the possible. Okay, so that you have to analyze carefully what is M and what is N. What part you remove, what part from your N you remove, so that the resulting equation becomes exact. So this is a guess method. And you can also look at here. So this, see, one of the other thing is here is both of them are not homogeneous function of same degree, right? Because M is not homogeneous, right? Because first term is of degree 5 and second term is of degree 4. So it's not homogeneous. It's not falling into the part, into that what you say, that's y into f of xy and x into f of xy. That's a special case also, it is not possible. Okay, now you can also look at the case dou m by dou y minus dou m by dou x, whether it contains the factor of m or n, and then you apply the respective method in that case. Okay, and so, and another method is like you simply multiply by x to the power a into y to the power b, both sides. Okay, and then you try to identify a value and b value. So what is a value is -3, y value is -4. Okay, so that's a one another way to look at. You multiply both sides by x to the power a into y to the power b and assume that resulting equation becomes exact. If you are able to identify the value of a and b, okay, then you are through. Okay, so that's it means you are taking a chance. Okay, you are writing some analysis part and you are solving some mathematical expression. Okay, and at that, if you are able to decide what is the possible value of a and b, so that this resulting equation becomes exact. Okay, right. So this is the intuition method, a guess method, you can say guessing method. Okay, and also you can also look at here. You can apply here variable separable method as well. So we don't need to go this huge analysis part here. Okay, you can indeed you can apply the variable separable method here. But I want to show that that there is a loss of solution. So that's why I taken in consideration. Okay, right. So I think let's complete it and try to find out that family. So now this equation is 2. So 2 is exact. So therefore there exists f of x comma y such that dou f by dou x is equals to, and dou f by dou y is equals to, I'm just going to fill up, I think, okay, it's going to be 1 by x square minus 4 by x cube. And what is dou f by dou y is minus, I will take inside, so 3 pi y to the power 4 minus 1 by y square. Now integrate partially with respect to x. So I am leaving, okay, this you have to fill it up, okay, in your notes. So if you are integrating with respect to x, what it will imply is f of x comma y is equals to minus 1 by x and minus 2 by x square. I think minus plus here, okay, and plus some constant, or it may be a function of y as we discussed. Okay, because when you differentiate partially with respect to y, so this derivative is 0. Okay, partially with respect to x, the derivative is 0 of this. Now from here you can certainly find dou f by dou y is equals to phi dash of y. Now, since that equation 2 is exact, so that will so this and this together implies what? Phi dash of y is equals to 3 by y to the power 4 minus 1 by y square. So now integrate both sides so that phi of y is equals to, so minus 1 by y cube, right? So the derivative of this is minus 3 by y to the power 4. So minus 3 is cancelled. So this is going to be plus 1 by y plus constant, right? So this is a phi y. So you have the final curve, or you can say final one parameter family. So this implies f of x comma y is equals to minus 1 by x plus 2 by x square plus 1 by y minus 1 by y cube plus so cos. So you can certainly see y equals to 0. That does not exist. This one parameter family is not continuous. Okay, right. Now, similarly, we can solve the another problem here. So I can give you for this case, what is the mu guess I'm telling you is, now look at here. So now this is what is dou m by dou y is equals to x time cos y, and for this case dou n by dou x is equals to 2x cos y. Okay, so if there was 2 here, yeah, true, means this is the exact differential equation, but there is no 2. Okay, so what you can do is, see, dx coefficient function of purely is a function of y is there, which you can remove. Okay, and from here you can remove the function of x. You have this is x square plus 1 upon this. I can choose this mu here. Okay, after which if I multiply, what you will remain is x by x square plus 1, and you have this is going to be cos y by sin y. X square plus 1 will get cancelled. Okay, and the resulting equation becomes the exact differential equation, and you are going to you can solve in the same fashion. Okay, right. So we have also looked for this special integrating factor. So which I've already spent too much time for this. That we have already seen that what will be the possible integrating factor if this for the non-exact is a function of x only. Then we have this one. Okay, that we have already seen. Okay, that exponential of e to the power integration of g of x here dx space. Okay, that we have already seen. Okay, and similarly, so here is I must say dx, here must say dy. Okay, right. So that we have already discussed. See the difference. Okay, now this third problem here, I will leave this as an exercise. It's just only verification. Okay, is homogeneous, and assume that that is not that is uh, homogeneous functions of same degree. Okay, and assume that that is not exact, and then you try to m by mx plus ny, n by nx plus ny, and try to show that to m by the resulting equation becomes the exact differential equation. This only that means verification. Okay, so first problem here I can look at here. So find an integrating factor for each differential equation. So let's look at the first problem. Okay, the first problem, first part. So 1a. Okay, so I may give the final integrating factor. Solution you may find. Okay, so the equation is 5 times xy plus 4y square plus 1 dx plus xk plus 2xy dy equals to 0. So your m, this is your m, and this is your, and what is dou m by dou y is equals to 5x plus 8y. I hope you are good enough to ask this partial derivatives. Dou n by dou x is 2x plus 2y. So it is very clear from here, dou m by dou y is not equals to dou n by dou x. Okay, so this you can see. So this becomes one is non-exact, and it will not take a more than a m is not homogeneous function. So you no need to check with n. N is a homogeneous function of it. You must look at dx coefficient right at the first stage. It's not a homogeneous function because of the constant term at it. Moreover, you cannot take y outside. So those method 3 and 4 will not be applicable here. Straightforward. Now, what you can look is the difference. Okay, so that you can look at. So I'm just going to look at the difference now. Now, dou m by dou y minus dou n by dou x. I'm just going to look at the difference. So this minus this, so 5x minus 2x is 3x. 8y plus 2y is 6y. So that's going to be 3 times x plus 2y. Right. Now, if you look at this n coefficient, n here dy coefficient and dy coefficient, see, factorization of m is almost not possible more than that. What you can do here is for n, it is possible that x into x plus 2y. I can rewrite this in the factorization. Okay. Now you can see this difference contains factor of n, and after removing that, it remaining only function of x only. Okay. So keep it not that if you are removing the factor of n, remaining should be function of x only. If you are removing the factor of m, remaining whatever is going to be remained here, that should be function of y only. That you have to keep in mind when you have divide by m, function of y only. When you divide by n, function of x only. Okay, that we have already looked at. So now this implies dou m by dou y minus dou n by dou x divide by n is equals to 3 times x plus 2y divide by x times x plus 2y. So that's equals to 3 by x, and which is function of x only. Function of x only. Now see that another way is to see this here whether you are whether you have to look dou n by dou x minus dou n by dou y or dou n by dou y minus dou n by dou x. Whatever is remaining in the whatever is there in the denominator, that will be sitting after the minus sign. If you go back and check for function of y only, you have this is when you are dividing by m. So you are taking the difference dou n by dou x minus dou n by dou y. So whatever is sitting here, that is after minus. So what that corresponding one will be present here. Okay, so this is how you can taken care whether this difference will be taken or this difference will be taken. If you divide by m, you can match after the minus. If I divide by n, dou n by dou x will be after the minus. Okay, now so this implies integrating factor, that is nothing but the function of x only, that is going to be e to the power integration of 3 by x dx, and which is nothing but x cubed. Right? So this is going to be x cubed. So now you can multiply the equation by x cubed. Okay, so multiply 1 by x cubed, that's the integrating factor, we get we get, if you multiply by x cube, okay, what you will get is 5x to the power 4y plus 4x square y square, sorry, 4x cube y square plus x cube time dx plus x to the power 5 plus 2 times x to the power 4y dy equals to 0. Now, in the new equation, you have now, this is m, or you can denote it by m tilde, distinguish from this one, and this is your m tilde. You can certainly verify that m tilde by dou y is equals to, right? And what is dou x is going to the power 4 plus 8x cube y. So this you can say 2. So this 2 is exact differential equation. Therefore, there exists a function such that dou f by dou x is equals to this m tilde, dou f by dou y is equals to m tilde, and then you can solve. Okay, right. Now, the second problem, similarly for the second problem. So, so I just like, okay, which case it will fall into. Now, I may miss the step here now. Okay, so you have, this is going to be y square time x plus 1. You have, this is y square time x plus 1 plus y dx plus 2xy plus 1 dy equals to 0, right? Yeah. Okay. Now you look at this and look at this and now see, this is not homogeneous. Okay. So we can't talk about that part. This is also not y you can take out. Okay. So from here m I can take y out. What is remaining is, okay, is going to be x into y plus y plus y, so plus 2y. Okay, so which is not a function of x into y, because x into y. See here, the second term is not a function of x into y.
Sir,
Yes.
sir, we took y out, so it will be xy plus y plus 1.
Okay. Sorry. Yeah. So you're right. So yeah. So x y plus 1. Okay. So we are not worried about. Okay, constant term can be treated as a function of any variable because you can write to the power 0. Okay, now this term is okay, but the second, this middle term is not okay. Okay, so this also not fall into that method. Moreover, you can see dou by dou y is equals to, you have 2y times x plus 1 plus 1, and dou n by dou x is equals to, this is going to be 2y. See, this case also no need to verify. First, you look at the n as well. There is no possibility to take x outside. So that method straightforward strike off. So again, I tell you that this will come only after the practice. Okay. Right. Now, so this equation is not exact. So this you can say 1. So this implies 1 is not exact differential equation. Now, what you can look is, let's say, dou m by dou y minus dou n by dou x is equals to, Okay, so 2yx plus 2y plus 1. So 2y will get cancelled. So what you have remain is 2x times y plus 1. Now, see, it is nothing but the exactly n only. So this implies dou m by dou y minus dou n by dou x divided by n is equals to 1, which is a function of x only. Or you can say which is a function of y only as well. But our interest, when you have divided by n, our interest is treat it as a function of x only. So we can certainly write it write the integrating factor. So this implies integrating factor is equals to mu of x, that is going to be e to the power integration of 1 dx. So that is going to be e to the power x. Okay. Now resulting equation. Okay. Now multiply 1 by e to the power x. So what you will get is you have e to the power x time y square x plus 1 plus y dx plus 2x e to the power x into 2xy plus 1 dy equals to 0. Now you can verify about, we can verify that the resulting equation becomes exact. So this is your, let's say, m tilde, this is your m tilde. So you can verify dou m tilde by dou y is equals to, so e to the power x time 2 2y, so 2xy plus y plus 1. Okay, and what is dou and dou x? So that is equals to e to the power x time first function as it is, second function derivative 2y plus e to the power x time 2xy plus 1. So here 2y is missing. Okay, so that's in total e to the power x time 2xy plus 2y plus 1, which both are equal. And so the resulting second equation becomes exact, and you can right. So now, so we have completed exact definition today. Now we are going to look at now very special form, which is known as Clairaut's equation. Okay, so which is of the form this. Okay, y is equals to px plus f of p. What is p is, here is p equals to dy by dx. So this is not a first, this is a first order differential equation, but it may be linear, it may not be linear, because f of p is there. So it may be possible that it's a transcendental function, sine of dy by dx. Okay, it may be dy by dx whole square. So for example, you may have, this is y equals to px plus p square. And another example is y equals to px plus sine p. Another example is you can have px plus e to the power p, and so on. So such examples are possible for this special form of Clairaut's equation. Okay, so but it is easy to solve. Okay, so how to solve this equation is, now see, Clairaut's equation is given is y equals to px plus f of p. Means it may be any of the following above type. Okay, right. So now from here, now differentiating both sides with respect to x. Okay, so that will imply dy by dx is equals to p plus x times dp by dx plus, this is a product rule here, because p is dy by dx and it's going to be a function of x depending on x, and you have this is f dash of p times dp by dx. Now you can note that dy by dx and p both are the same thing, so that is going to be the cancel. So this implies you have x plus f dash of p times dp by dx is equals to 0. So now there are two possibilities. So one possibility is either x plus f dash of p is equals to 0, or dp by dx is equals to 0. There are two possibilities. Okay. Now assume that x plus f dash of p is non-zero. Then you have the solution. Okay. So now case x plus f dash of p not 0 implies dp by dx 0, and what it is, p is equals to constant, some constants, let's say a. Or you can eliminate p. This is, you can say p equals to a. This is, you can say 2, and this you can say as 1. So this you can say as 1. Okay. So once you eliminate p, eliminating p, okay, between 1 and 2. So what you get is y equals to ax plus f of a will be the solution. So this is an arbitrary constant. So only one parameter family have already obtained, which will be the general solution of this Clairaut's equation. Okay. Now what will happen if suppose x plus f dash of p equals to 0? Okay. So let's say in case if you take x plus f dash of p equals to 0. Okay. Then solve this equation. Okay, f dash of p equals to 0, then solve this equation and find out the solution for this. Okay, so find the solution for this means y is equals to some let's say g of x comma y comma or we can say g of x comma c. Okay, so you try to find out one without you can say without arbitrary constant. That is a possibility. So let's say arbitrary constant, you are not going to add it. Okay, because the general solution can be obtained from this case. Okay, if you are interested in finding the general solution, that can be obtained from this case. So in the case when you are taking x plus f dash of p equals to 0, then you find out the solution y equals to g of x of this equation. Now, if this equation, so if this solution, this obtained solution will also satisfy the one, then this solution is known as singular solution. Okay, it's not a general solution because it cannot be obtained from the general solution. Means, what do you mean by obtained from general solution? Means if you are going to choose this arbitrary constant suitably, so there will be infinitely many solutions, right? But in these infinitely many solutions, this solution will never be falling. So this is a solution which can never be obtained from the general solution. That's the meaning. So you can keep on substituting a value here and there and all. So you consider the set. That set will not take this as a part of it. So this has some associated name is called singular solution. Okay, right. So this may exist or may not exist. Okay, so this may be possible. So it may be solution or it may not be a solution. So if it is solution, then it's a singular solution. Okay, right. So now, so I have already explained this. It's called a Clairaut's equation. It's known as Clairaut's equation. Now differentiating will lead to this. Okay, so assume that this is non-zero, and then you have the dp by dx equals to 0, which will result p equals to some arbitrary constant, and the general solution will be y equals to cx plus f of c. Replace p by c. So in particular, if you take the example like y is equals to p times x plus p square. So this is Clairaut's form. So what is the general solution of this? Is nothing but y times cx plus c square. Similarly, you have another, let's say y equals to px plus sine p. What will be the general solution for this is c times x plus sine c. Replace p by a constant, that's it. So it's a very straightforward answer for this case. So Clairaut's equation is a very special type equation where the solution can be obtained simply by replacing the dy by dx by a constant. Okay, general solution. Now, assuming if in case x plus f dash of p equals to 0, then eliminating p between this may lead, so this is important, may lead to an extra solution which is called singular solution. That is not a member of the obtained one parameter family solution in the above final step. So this is called a singular solution which may exist or may not exist. Okay, so for this case, if I am interested in finding the singular solution, so let me have here. So I have this equation, let's say y equals to px plus p square. So note that we are having this notation p for dy by dx. So this is a Clairaut's equation. So this is here, you can say px plus p square. Okay, let me, so what you can say, differentiating both sides with respect to x. So this implies dy by dx equals to p plus x times dp by dx plus 2 times p times dp by dx. Now, you note that this dy by dx and p are same. So this implies x plus 2p times dp by dx equals to 0. So as let x plus 2p is non-zero, then dp by dx is equals to 0. This implies p equals to c, and therefore general solution will be y equals to cx plus c square, this eliminating p. Now let in the case, okay, let x plus, sorry, let x plus 2p equals to 0. So the other part. Okay, so what will happen is x plus 2 times dy by dx equals to 0. That you can solve by using variable separable method. So you have 2 dy is equals to minus x dx. So this implies you have, this is integrating both sides, 2y is equals to minus x square by 2. So this implies y equals to minus x square by 4. See, y equals to, this is c times x, and this is far away from there. So y equals to x square by 4. This is not, so that was the earlier was a linear case, general solution, and this is a quadratic curve. Okay, so they are not the same thing. Okay, so this certainly not fall into that. Now you have to verify whether this is going to be the solution of original equation or not. So to verify, you have to get what is p here. What is p is nothing but minus x by 2. That is straightforward. So you can obtain the right side. What is that? Px plus p square. What is that? That's going to be minus x by 2 times x plus x square by 4. So this is minus x square by 2 plus x square by 4. So it's going to be minus x square by 4. And that is nothing but y. So this satisfies the original equation. So hence, this is a solution. This is a solution, and which is called singular solution of the original problem. So similarly, you can go for another case, y equals to px plus sine p, or and so on. Okay. Not that, yes.
Sir, in this arbitrary constant will not come?
No,
When we integrate?
no, because we are talking about the singular solution. So arbitrary constant will come in the general solution part. Okay, so general solution will already taken care of one parameter family. Okay, so okay, so this we in the general. Okay, so general solution will already taken care of that one parameter family or one arbitrary constant. So in this case, in the case of obtaining singular solution, the arbitrary constant, no need to add it. Okay, because you can fix it, c equals to 0. Okay, yes. Because these arbitrary constants. So singular solution will not carry any arbitrary constant, that you can keep in mind. Okay, right.
Yes.
Right. Now, let's look at some second order differential equation. Okay, where we can reduce it to reduce the order of it. Okay, means we can reduce the second order differential equation to first order differential equation. So there are some special cases, means so that we can handle these cases specially as like in the first order differential equation. Okay, so the general second order differential equation will involve x, y, y dash and y double dash. Okay, so it may be linear, it may not be linear. We are not specifying anything. So now let's assume that the dependent variable is missing. Okay, means explicitly y is not appearing in the equation. Okay, for example, you have let's say x plus y dash plus let's say y double dash equals to 0. Let's say this equation, very simple equation where y is not explicitly appearing into the picture here. Okay, right. So what you will do is, in that case, you can replace this y dash by p. So then you have y double dash is equals to dp by dx. And then if you use this as a substitution here, what will equation is x plus p plus dp by dx equals to 0. Now this equation is linear in p and x. Okay, or you can say this equation is first order differential equation in p and x. So solve, okay, solve this equation, then you solve this y dash equals to p. You will tackle this if this its dependent variable is missing. Okay, so this is here, so that is it, the equation of the form this. In this case, we introduce a new dependent variable p by, so you have, this is a transformation, you can say. So this substitution transform above equation into first order equation in p and x, like here. You know now many method to solve. Okay, homogeneous case, non-homogeneous, separable form, okay, exact differential equation case, and so on. Okay, so it's purely is a function of p and x. Means you can say x comma p dash. Okay, which you can handle it. Okay, right. Now in another case, let's say independent variable is missing. Okay, so for example, now you can take y plus y dash plus y double dash equals to 0. So x is not appearing explicitly. Okay, implicitly, you know, y is a function of x. So x, it depends on x, but explicitly it is not appearing in the differential equation of second order. Okay, so what you can do is still you can use this transformation as p equals to dy by dx. Okay, now what other things? So now what is y double dash is what? So now if you differentiate p with respect to y, so from here, see, earlier we were having dependent variable missing, so we are taking dp by dx. Okay, now we are going to take dp by dy in the case when independent variable is missing. Okay, because p is a function of x and you can treat x as a function of y, because when you take this is a independent variable is missing, so you have y is a function of x and you have y is a function of y is equals to some function of x. Okay, that's a 1-1-on-2 transformation. So x is a function of y. You can certainly look at this. Okay, so this implies what is dp by dy from here. So first you differentiate with respect to x, d square y by dx square into dx by dy. So chain rule. Okay, so what is dx by dy is 1 by p. So it is 1 by p time y double dash. So this you can replace now y double dash by p time dp by dy. So when you use this transformation and treat p as a function of y, okay, then you have used this transformation, and then the resulting equation will be linear, will be first order equation in p and y. So like here, so if you replace p equals to dy by dx and y double dash equals to this, so the equation will be is So resulting equation, okay, will be you have this is going to be y plus p time dp by dy equals to 0. Okay, so this is first order differential. Solve this by using the previous methods. Okay, you can see whether you can apply the variable separable or you can apply the say you can say this is a dp by dy. So you try to find what way you can solve this equation. Okay, I think so you have the resulting equation is y plus p dp by dy. You can use the variable separable, I think so. So this is p plus p time dp by dy. Whether you can do or not, I have to see. This is minus y. Okay. What you do for now is okay. So what you can have here is dp by dy is equals to minus y minus p divided by p. So you can see numerator is a homogeneous function of degree 1, denominator is a homogeneous function of degree 1. So both are, so together, this numerator denominator, if you take consideration, it's a homogeneous function of degree 0. 1 minus 1 is 0. So it fall into that case. Either you apply the exact differential equation method, or you can use the transformation as here p equals to some vy. Okay, and then you can solve. Okay, right. Fine. So these both two cases can be handled, okay, by reduction of order. So likewise, in the first problem, y is missing. Okay, so I will use the transformation p equals to dy by dx, and then dp by dx is y double dash. dp by dx minus p is equal to 3x square. So this implies dp by dx p by x is equals to px. In p and x, whose integrating factor is nothing but to the power integration of minus 1 by x.
Sir, there is lag.
Sir, your voice is breaking.
Okay, my voice is fine now.
Sir. Yes, sir.
It's fine now. Okay.
Yes,
Okay.
sir.
So means slide was okay, right? This was fine.
Yes, sir.
Yes, sir.
Yes, sir.
This was one.
Only the examples that yes, when
Okay.
it is ready.
Yeah. Okay. So now see, I have seen here y is missing. Okay, y is missing, and it is a second order differential equation. So I can use this transformation as p equals to dy by dx, then dp by dx equals to y double dash, which transform it. So if you replace y double dash by p times y double dash by dp by dx and y dash by p, okay, what is the resulting equation is this. Now you can make the coefficient of dp by dx by 1, divide by x both sides. So what is resulting equation is first order linear differential equation whose integrating factor is e to the power this p coefficient, that's minus 1 by x, integration of that dx, and that is nothing but x to the power minus 1. Now you can write the final solution of this equation. So the solution will be p time x to the power minus 1 is equals to integration of 3x time x to the power minus 1 dx plus some arbitrary constant c. let me take this is C1. Okay, let me say C1. So this is going to be, so x will get cancelled. Your integration is 3x plus C1. So this implies, so this certainly implies you take x on this side. So this implies P equals to 3x square plus C1x. What is P is? P is dy by dx. That's equals to 3x square plus C1x. So this implies the solution of this equation is, you can use again variable separable. So y is equals to x cube plus C1x square by 2 plus C2. See, not that in the general solution of second order differential equation, you have two arbitrary constants. In third order, you will get 3 arbitrary constants in the general solution. So, and see, I can also rewrite it as x cube plus C1x square plus C2 sometime. Why? Because it's a generic constant. We can say this is generic constant. So C1 by 2 you can replace by some new constant C1. So that's not a problem. When you have this, suppose you are going to impose some condition here, then you will get them uniquely if it is required. Okay, so that is also fine if you replace C1 by 2 by C1. Okay, right. Okay, now the next equation, y double dash plus k square y. So I think y double dash plus k square y is equals to 0. So x is missing. So I will take p equals to dy by dx. Then we have already derived that y double dash is equals to p time dp by dy. So this transforms the original equation as p time dp by dy plus k square y is equals to 0. So you can use variable separable method here, show surely. Okay, so this implies p time dp is equals to minus k square y dy, right? Yes. Okay, so now you can integrate both sides. What you will get is p square by 2 is equals to minus k square y square by 2 plus c, some c1. Okay, so now this implies p square or p square is equals to minus k square y square plus 2c1. So this implies p equals to plus minus square root of 2c1 minus k square y square. So if you are interested only in the real solution, right? So this certainly should happen. Means when you are obtaining, when you are fixing some arbitrary constant here. Okay, that should argument in the square root should remain positive, greater than 0. Okay. Now this is p is plus minus, so this implies dy by dx is equals to plus minus square root of 2c1 minus k square y square. Now you can use again variable separable method, and you can use that standard integration formula, right? Integration of 1 by square root of a square minus x square. So that will be turned out in terms of sine function, right? Okay. So that that you take care. Okay, that's final solution you can write with addition some constant. So you have C. One more thing. See, you have two here p square. Okay, quadratic equation in p. Anyone you are having. So you will find two solutions. Okay, so what will obtain is you will have y equals to some let's say g1 of x comma y comma c. Okay, and some c1 comma c2, and y equals to some g2 of x comma y comma c1, or you can say not of x comma y. So you will certainly obtain, yes, maybe. Okay, so what you will obtain is in the journal you will obtain two parameter families, two functions, okay, with one plus sign with one minus sign. So one family is g1 of x comma y comma c1 comma c2 equals to 0, and another is g2 of x comma y comma c1 comma c2 equals to 0. Okay, so you will obtain two solutions here. Okay, right, for this. But those two equations will contain only two arbitrary constants. So with plus case different, plus minus case different. Okay, right. Now, and we are at the end of now for the first order differential equations. And we are going to look at now one of the application, you can say, that's going to be orthogonal trajectory. Okay, so which means like your this what are the applications? So it means if you are going to uh, launch a satellite into some planet orbit, okay, so you have to find a trajectory through which it should travel and reach to that orbit, and then it will move around there and in some particular trajectory only it should follow. So there that you can consider as a part of your uh, application of orthogonal trajectories. Okay, so but how would you obtain this orthogonal trajectories? So you have been given with a family. So orthogonal trajectory means what? You will in that family of another curves. So you take the angle between those curve and the original curve. That angle will be right angle. Okay, means tangent. So when you have taken in the Cartesian coordinate, so let's say this is one parameter family g of x comma y comma c equals to 0. Be a given family of curves in the xy plane. For example, you can take you can say one of the circle x square plus y square equals to some c square. This is one parameter family. Okay, circle. So means you will say this radial directions. Okay, means like lines passing through the origin. Okay, all lines passing through the origin and the tangent to that line and tangent to that the point will be intersected right angle triangle that I will show you. Okay, right. So let G be a given family of curve in the xy plane. So what is first job is to eliminate this arbitrary constant after differentiating. So if you differentiate, so once you differentiate, you will get another family of G1 of x comma y dash. Y dash is dy by dx, and maybe this c equals to 0. This arbitrary constant still may be possible by because c into x is there sometime. Okay, so what you have to do is first you have to eliminate this arbitrary constant. Then you will obtain a resulting equation, let's say g2 x comma y dash equals to 0. That's a means you are trying to obtain the corresponding first order differential equation. And then what you will do, see that if you want to cut at right angle triangles, you know that dy by dx is replaced by minus dx by dy. That product of these two slope is minus 1. Then we say that that two angles are right angle triangles. You like say two lines are cutting at right angle triangle. Okay, so similar concept here. So you are going to replace in the obtained family y dash or dy by minus dx by dy, and then you solve it back. Okay, then you saw after replacing y dash by minus dx by dy, you are going to solve the equation. You will obtain a new family where at each point you will see that the because the derivative is for the family is dy by dx and tangent, another family has the tangent is minus dx by dy. So both are nothing but the intersecting at the right angle right angles. Okay, so that will be the procedure for obtaining the orthogonal trajectory for which okay, that intersects a given family of curve at right angles. Okay, right. So find, so let's say I will come back to your circle equation. Find an ODE for which the given family is a general solution. Okay, then replace dy by dx by minus dx by dy and solve it back. Solution of the previous step will give the orthogonal trajectories for the given family. Okay. Okay, so you can I will just come back to your equation of circles. Okay, and so if you draw the graph, okay, so you have this circle. Okay, so at any point, okay, at any point, okay, x comma y on this circle, okay, and if you draw the line passing through the origin, okay, and if you look at the angle between the tangent at the point, okay, look at the tangent at this point and the angle between this line is going to be 90 degrees. Okay, radial directions are always the normal to the curve. That if you are able to recall that part, and if it is already done with you in the intermediate session. Okay, so means all line passing to the origin. So you can have another line is here. So you take this point and you have, if you draw the tangent, so that will be intersecting at the right angle. So now look at this family. Now x square plus y square equals to c square. Now differentiating both sides with respect to x. So what we will obtain is 2x plus 2y dy by dx is equals to 0. Okay, so 2 will get cancelled, 2 will go towards 0. Now what is obtaining is you have dy by dx is equals to minus x by y. Okay, now to obtain the orthogonal trajectory family, what you can do, replace dy by dx by minus dx by dy. So once you replace, what you will obtain is dx by dy, minus side will get cancelled on both sides. That's going to be is equals to x by y. Okay, so this implies dx by x is equals to dy by y. And if you solve this equation, it's ln x, integrating both sides, what will obtain? So on integrating both sides, what you will obtain, ln of x is equals to ln of y plus arbitrary constant. That arbitrary constant you can also choose ln of c. So what is going to be c times y is equals to x, or you can say this y equals to 1 by c. Okay, so you can treat this as c1. So 1 by c1, okay, x by c1, or you can say c2x, which you can replace by 1 by c1. So this is nothing but the straight lines passing through the origin. It will cover all the straight lines passing through the origin. Okay, you take any straight line passing through the origin. So these are the orthogonal trajectories for the family of circles centered at origin. See, radius could be any c square here, arbitrary constant. It may be as large as possible or it may be as small as possible. So all straight lines passing through the origin will lead to the orthogonal trajectory of the family. Let's consider this ellipse, intersecting family of ellipses at right angles. So now you have this is a straightforward differentiating both sides with respect to x. So what you will obtain is x plus 2y dy by dx is equals to 0. So this will obtain, this will give you dy by dx is equals to minus x by 2y. Okay, now replace dy by dx by minus dx, replace dy by dx is equals to minus dx by dy. Okay, because this is a corresponding first order differential equation. So this implies you have dx by dy is equals to x by 2y. Okay, now what will be the solution? You have dx by x is equals to dy by 2y. If you integrate ln of x is equals to 1 by 2 ln of y plus some ln of c, constant, arbitrary constant. So you now take 2 on both sides, and what you will obtain a family of parabolas by c of x square. Because 2 will get here, so 2 times ln of x is ln of x square. Okay, some c square x square you can say. Okay, or you can say here with minus sign, that also it will solve your problem. Okay, so y equals to c square x. So all means the parabolas. okay, passing through the origin. Okay, so you have the family of parabola which are passing through the origin, so that will be turn out at the orthogonal trajectory for this ellipses. Okay, right.